In example 2, we're going to talk about radicals and perfect squares. We're going to start by making a list of perfect squares. Now, perfect squares are something that's multiplied by itself. So for instance, 1 times 1, or 1 to the second power, is equal to 1. So 1 is a perfect square. 2 to the second power is equal to 4. So 4 is a perfect square. So 1 is a perfect square, 4 is a perfect square. If we take 3 to the second power, we get 9, so 9 is a perfect square. 4 to the second power is 16, so 16 is a perfect square. 5 to the second power is 25, so 25 is a perfect square. 6 to the second power is 36, so 36 is a perfect square. 7 to the second power is 49, so 49 is a perfect square. So all these numbers are perfect squares, and the list can go on and on. So we ended up with 7 times 7, so 8 times 8, or 8 squared is 64, so 64 is a perfect square. If we look at 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, and it goes on forever. So again, these are more perfect squares, but they go on forever. So you could do 14 times 14, 15 times 15, 16 times 16, and so forth. Here's the general list of perfect squares that you will need. Every once in a while, you might need one that's a little bit bigger, and that's okay, but most of the time, you'll find a perfect square that you're going to need to use in these two lists. Now, as we scroll down and take a look at our properties of radicals, the product property says that the square root of a product equals the product of the square roots of the factors. And remember, product means multiplication. So if I have the square root of a times b, I can split that up into two separate radicals, the square root of a times the square root of b, when a and b are positive numbers. Underneath here, so for example, if we look at an example, I could say that the square root of 12, which is the same thing as the square root of 3 times 4, is equal to the square root of 3 times the square root of 4. So basically what I'm doing is I'm taking a number, breaking it down into two parts, and then I can split up those parts and multiply them together. An expression with radicals is in simplest form if the following are true. No perfect square factors other than 1 are in the radicand. No fractions are in the radicand, and no radicals appear in the denominator of a fraction. We are going to focus really in this chapter on the very first one to make sure that there are no perfect square factors other than 1 underneath that radical. So if you have any questions on this, let me know. Otherwise, we're going to move on to example 3.